Hello! Today we are going to do our lecture on the Coriolis effect. If you will give me a second to get ready. Actually, the very first thing you're going to do is a video worksheet. So let's see if we can find that for you. Of course, it's not as simple as I thought. That's fine. So we're going to be doing our video lecture on the Coriolis effect. The very first thing, however, that you are doing is a worksheet on the Coriolis effect. You're going to watch a video and answer the questions. I'll pull up the worksheet for you. It'll be posted to Canvas for your viewing pleasures. You're going to fill in, some of them are actual questions, but the majority are fill in the blank. So answer these 4 questions. These 2 are one word. This one you'll have to infer from the hydro unit the answer. And then these ones, if they have like capital letters and a slash, you're going to highlight whichever you think is true based on the video. Fill in the blank, pick, fill in the blank, pick. Should be pretty easy. The video is not that long, and it gives an awesome description to the Coriolis effect and what's actually going on as far as our global winds are concerned. If you will give this 1 second, it appears to be having some issues. You're not watching the video. You're also not doing this. This is for later. Okay, so here's the video again that you're going to watch on the Coriolis effect. You're going to fill out the answers. Here we go with our notes though, in reference. Make sure you're on the notes page. We are defining convection at the very top. I would like you to define it as the circular motion that happens when warmer air or liquid, because it happens with water, which has faster moving molecules, making it less dense, will rise while the cooler air sinks. So it's this back and forth cycle that we get. It's called convection. We've heard of convection ovens that work similarly. We have convection in our ocean currents, but in this case we're talking about the convection that happens in the air. So as the air passes by, if you're looking at the little diagram right here on the bottom, as the air passes over the ground, which is warm due to the natural heating of the earth and the mantle below it, it warms up. And as you know, warm things are less dense, so they rise. And it rises high up into the atmosphere. But what happens, as you know, based on the troposphere, as we increase in elevation or height above the Earth's surface, we drop in temperature. That's what this graph right here tells us. So as the air that was warm rises, it cools down. And eventually it hits a point where it becomes so cold that it will actually sink back down to the ground, because remember we talked about air molecules or liquids. As they cool, they're getting closer together, making them more dense. So that dense air sinks down to the ground where it is warmed up again, and the cycle repeats itself. That's convection. That's a major thing that happens, a major phenomenon or process that happens in the atmosphere, in the oceans. It's something that you've definitely got to understand. So if you have any questions about how this heating and cooling and heating and cooling and heating and cooling current and cycle happens, make sure you email me and ask me, because this is really important. Basically, the ground warms up the air. We know that warm air rises. As it rises, it cools down because of the temperature of the atmosphere, and then that cool air sinks back down to the ground. Now, we've got some cool things that happen as a result of this convection. This is a video. I'll post it for you. It's convection of water, but it is pretty cool, and you might have already seen it, actually. I do believe we have. So you can watch it again. It outlines the convection in the water. And again, one of these cool things that results because of this convection is the jet stream. So we call the jet stream because airplanes will often use the system in order to get from place to place, because it's a band of strong winds in the upper atmosphere. They form when a warm air mass meets a cold air mass. Specifically, this happens in our around 60 degrees latitude, give or take. In some parts, our jet stream is bent below, in some parts it is bent upwards, depending on the topography of the ground below it. But that's the jet stream. So it's labeled that or called that because airplanes will actually use this to get from one place to another, and it really, as long as they're not going against it, increases their speed and can quickly get them from one place to another if they're close enough. So like if I wanted to fly from what is that, Washington to maybe the other Washington, Washington, D.C., my plane might actually use this jet stream to get from one place to the other quickly. So it'll have the wind against it, the wind at its back, meaning that it'll move much faster than it normally would, which is pretty awesome if you are an airplane driver or a traveler. So that's because of this phenomenon of the warm air mass meeting the cool air mass. Now you learned, or you should have learned in your video, or you will learn depending on when you've watched it, that the jet stream actually causes the jet stream actually the difference between the two. So if I have a really, really warm air mass and a really, really cold air mass, my jet stream is going to go much faster. So in the summer months, we actually have a slower jet stream than we do in the winter months. That difference in the air temperature plays a part in how fast this is moving. Okay, picking back up, sorry I had to take a little break. But anyways, so the difference between the air masses, so whether it's really warm or really cold, matters. So if I have a great difference, so there's an extreme difference between the cold and the warm, it'll actually create stronger winds. Remember we talked about how warm weather creates low pressure systems or warm air, and cold air creates high pressure systems. And the greater the difference, the more wind we'll have. The same thing happens with our jet stream. So it is actually faster in the winter than it is in the summer. Fantastic. So our next thing that we're going to talk about, besides the jet stream, are air currents. So this is a concentrated areas of wind, mainly due to the differences in pressure and or temperature or convection. So we have these predictable air currents that we get, along with our major what do we call them? Surface winds, like our trade winds and our westerlies and our easterlies. We call them air currents. So it's a movement of air, pretty much, wind. And remember, remind me, which way does air flow? From areas of low pressure to high pressure, or from areas of high pressure to low pressure? It flows from areas of high pressure to low pressure. Again, remember that it is always trying to reach that equilibrium. So we're trying to make sure that, we're trying to reach the equilibrium where our air molecules are not only under high pressure. Remember, high pressure, think squeezing of the air molecules. So our air molecules don't really like that, so they would like to spread out. So they're going to move to areas of low pressure where there are less of them, so they cannot be as squeezed. When they do move like that, that's what actually causes the wind. Okay, and these are our winds that we learned the other day. If we start at the equator, the winds are from 0 degrees to 30 degrees north or south. We call those trade winds. Remember, they move in a curved direction because of the because of the way that the Earth spins, right? So our trade winds will move from the northeast from the northeast to the southwest. So you can see they curve over just like that. And then moving up from 30 degrees latitude to 60 degrees latitude, we have our westerlies winds. And very confusing, these are actually named from the direction that they're going. So our westerlies go from the southwest to the northeast. And then lastly, from 60 degrees latitude all the way to our poles, we have the polar easterlies, and they move from the northeast, again similar to the northeast trade winds, to the southwest. Again, that curve is due to the rotation of the Earth. And on the other side, we're seeing the movement of the air. So this is the movement as far as north, south, east, west. This like flat across the Earth. But the movement on our right-hand side of this, or left-hand side of the screen right here, we're seeing the movement of the air vertically. So the right-hand side of right-hand side of the screen, we're talking about our horizontal movement of air. Left-hand side of the screen, we're talking about our vertical movement of the air. Now we see specific pressure currents come about because of these different winds right here. So at the equator, we have an area of low pressure, and because of that, we get this circular movement of air. Again, our hot air is moving from the ground up into this, up into the, some of these are wrong, the colors, these are wrong specifically. Yeah, this side is wrong. So please only pay attention to the color of this side. So the warm air again rises, and as it cools, it falls. The warm air, this one is wrong too, rises, and as it cools, it falls. Maybe that one is right. And then the warm air rises, and as it cools, it falls. We get this distinct area of low pressure at the equator, high pressure at the 30 degrees latitude, and low pressure at 60 degrees latitude. Now, not necessarily, I might not want you to know these circular movements here, but I do want you to be able to predict that because this is an area of low pressure, remember we said that low pressure systems will often bring lousy weather. Think about that when you think about what's at the equator. We get lots of rain at the equator. Most of our rainforests are in the equator region of the Earth. So we get lots of rain right here. But in contrast, at 30 degrees latitude, we have, we think, happy weather. So clear skies and maybe a little cool breeze. But that is, that can indicate that these regions get less rainfall. And not in a bad way, just less excessive rain than its equator region right here, or the 60 degrees latitude up here. So again, this low pressure right here can indicate that this region or area has lousy or rainy or stormier weather than typical for that latitude. Like that is why England is right around here. England has characteristically rainy weather. That could be in part because of the low pressure that is over that 60-degree latitude line. Okay, and again, here is an example of maybe what you would see with our wind patterns. So this is the purple, and you can't, if you're tuning in online, you can't draw this in on your notes, so just please pay attention to what I say. This purple and yellow line right here is our jet stream. You can see that it will move. It will form or bend between a warm front and a cold front. Now remember, if this is really, really warm and this is really, really cold, this jet stream is going to go much, much quicker than anticipated. That is really all I wanted to point out to you with this graph right here. And then a student in your class, so one of your classmates showed me this awesome doodad right here. This is a website. It is earthnullschool.net. It's talking about the currents and the wind and the surface currents on the Earth, and you can see from these green lines the way that these currents of wind actually move, which is pretty awesome. You can see part of the jet stream right here moving across and picking up right here. Now these are going to change depending on high pressure and low pressure systems, but what do you see right here? That's interesting. What might you predict that circle spiral is? I hope that you predicted that that is indeed a hurricane. So one thing that we can do by looking and tracking these wind and surface currents is predicting weather events like hurricanes, specifically bad ones, so maybe people can better prepare. And then you can see in general, if we were looking at the equator right here, ooh, I don't know what I did. Okay, see if we can zoom it in. If we were looking at the equator right here, we can see the different movement of the winds right here, how this is moving in a general counterclockwise direction, and the, didn't know I could move it. So this is moving in a general counterclockwise direction, while this one is moving in a clockwise direction. That's because of the Coriolis effect. You can see the other jet stream right here pretty distinctly down here by Antarctica as the air currents move and flow. So you know, or you could predict that there is a warm air mass and a cool air mass on each side of these bands right here. That is really cool. All right, guys, have a great day. Goodbye.